Hi, this is just a recording for the in-class review we did. It's really not meant to be watched in its entirety unless you need to. It's really meant just for you to go through, try the problems, then maybe turn on the video and see how you did, or go back and just watch the part you need to watch. So, in solving by graphing, whichever line you graph first, I'm going to graph this one first, you need every single dot that will fit on the graph, because you want this graph to be really, really accurate. Because the other line is going to cross or intersect this line, and you want to be able to tell exactly where that is. So this first line then isn't ready to graph. We need to add x to the other side, and in adding x to the other side we get a positive x. Now we're going to divide everything by -1, which if you can do that in your head, that's fine. I get y equals -1x minus 6. So we're going to start at -6, and we're going to go down 1 and over 1. And that doesn't help us, so we're going to go back up the other way. And the minute we have a point where the lines cross, we don't need to make any more dots. You do need lines, not just dots. And you do need the point of intersection as your answer. So this is the work. It needs to be completed. That's your answer. This, the first line I'm going to graph is the top one this time, and it's a Hoy line. And that means it's horizontal. And you really don't need any dots here because you've got this grid line to follow. There's my horizontal line. The other line, I need to subtract x from the other side of the equal sign. Now I need to divide by 2. And I get y equals -1/2 x plus 4. That's going to start at 4 and go down 1 and over 2, and I don't need any more dots because it crosses. You need to graph the lines. You need arrows on the end. You need to make sure you put the point of intersection as your answer. To determine if something is an ordered pair, or to verify, or to show, you are going to show all the steps. You're going to plug in 1 for x and 3 for y, and you need to show that work. It's not something you're doing in your head or on your calculator. And you're checking if that's 9. So you're going to pick up your calculator, put that in, and it is 9. You need both those lines of work. This checks. You don't need the check mark, but that checks. It works. 9 does equal 9. So you then have to try in the second equation. And now you're going to see if that equals 10. You're going to put this in your calculator, you get -2. -2 does not equal 10, and that means this is a no. For it to be a yes, it would have to check in both equations. So here, we're plugging in -4 for x and 2 for y. So I have 2 times -4 plus 3 times 2, and I'm going to see if that's -2. And it is. So this checks. When the first one checks, you have to try the second equation. By the way, if this one did not check, you'd write no, and you don't have to check the other one. Now I'm putting 2 up in here for y. I have -1/4 times x plus 1. That does check. This is a yes. So the only real trick to number 5 is to notice that it's asking for the x solution, or the x part of the solution, and that means that it's asking for the front number in the ordered pair. Since the top equation tells me what x equals, I'm going to use the idea of substitution, and I'm going to substitute in the other equation where there's an x. We don't write the x, we replace the x with -4y. And I have 2y minus 12y equals 5. That's -10y equals 5. And when I divide, I get y equals -1/2. So we don't run into fractions a lot, but you can actually get fractions here. And that fraction's right over here, and you're tempted to go say that's my answer, but that's what y equals. To find what x equals, I need to go back and plug in and say -4 times -1/2 is 2. So my answer is actually D here, because it's asking for the x part of the solution. The next page is about substitution or elimination. So substitution is used when one of the equations reads x equals or y equals, and the top equation here reads y equals. You plug it into the other equation for y. You don't write the y, you write down everything else. That y is being replaced with 3x plus 5. Now you're just solving this equation, keeping track of all the signs, like that's negative 15. These combine to negative 7x. I'm going to add 15 to the other side and divide. That is the front number. And we talked about the fact that if you can plug negative 1 up here in your head, that's fine. I'll just show you where it goes. But it's 3 times negative 1 plus 5. And if you do that, you will get 2. And you don't need to show this work, you just need to make sure you get 2. When both equations read y equals, you're going to make an equation out of them. So I'm going to say negative 3x plus 5 equals 2x minus 10. My equal sign is right here, so I'm going to add 3x to this side, and at the same time I'm going to add 10 to that side. If you want to make more steps out of it, then do that. I get x equals 3. That is the front number. Again, to find the back number, I'm going to plug in, and it doesn't matter where. So if I use this second equation, I'm doing 2 times 3 minus 10, and that is negative 4. If you plug into the top equation, you'll get negative 4 also. Number 8, I'm not going to use substitution. I'm going to use elimination. In elimination, all the x's and all the y's and all the equal signs and all the numbers are all lined up. And what you really want with elimination is opposites. And I actually have opposites right here. Those are opposites. And that means they cancel. So when I add these together, I get 5x, and those cancel, and I get equals negative 20. And when I divide, I have my front number. So my front number is negative 4. And I'm going to plug into the first equation. 2 times negative 4 plus 5y equals 7. And I'm going to solve that equation. So I'm going to add 8 to the other side, or to both sides, and I'm going to divide both sides by 5. So I get the back numbers 3. This is set up for elimination, but I don't have opposites. What I am going to notice is that there's an invisible negative 1 here, and if I multiply it by 2, I'd have a 2 in front. But if I think about wanting opposites, the opposite of negative 2y is positive 2y. So if I multiply by negative 2, I'll have a positive 2y. When you multiply, you need to multiply all the way through the equation. You're going to leave the top equation the way it is. Every single thing in the bottom equation gets multiplied by negative 2. I get negative 6x, those cancel or eliminate, equals negative 12. So x is 2. I'm going to take that 2 and I'm going to plug it back in. I'm going to plug it in right here, and 4 times 2 is 8. Oops, that's a minus 2y. I'm going to subtract 8 from both sides and divide both sides by negative 2. And I get y is negative 3. If you chose to make the x's eliminate here instead of the y's, that's fine. As long as you get the same solution, that's all right. On 10, I'm just going to notice that in the x's, that's a 3x. If this were a negative 3x, those would cancel. So I'm going to multiply the bottom equation all the way across by 3. I have 3x minus 6y equals 7. Nothing's changing in the first one. Second equation becomes negative 3x plus 6y equals negative 12. Now both things cancel, and that means nothing's left on that side, and that means 0. This is not true. They are not equal to each other, and this is no solution. These would be parallel lines if you graphed them. They're no solution. Now I'm going back to substitution here. My top equation says x equals, so I can plug it right in here in the bottom equation behind the negative 3 where the x is. So I don't write the x. Instead of the x, I write y plus 5. I'm going to distribute. And these combine to 4y, and I'm going to add 15 to the other side and get 16. And when I divide, I get y equals 4. That's the back number. If I put 4 in here, I find x by doing 4 plus 5. That means the front number's 9. I just want to back up here for a moment. Just remember, if these two numbers had turned out to be the same thing, that's when you would get infinitely many solutions. So moving on to 12, it's all set up for elimination, but if you look around at something that eliminates easily, there isn't something. So something that works all the time, and specifically on this one, is to take the bottom number times the top, and the top coefficient times the bottom. Now, I did not use negative 5, I just used 5. Here's why. When I multiply here, I get positive 20x, and when I multiply there, I get negative 20x. So I'm not always using the sign with the number, because I'm trying to create opposites. So when I multiply by 5 all the way across the equation, I get that for the first equation, and all the way across in the second equation, I get this. Those are opposites. I have negative 7y equals 35, so y is negative 5. That's the back number. I'm going to plug negative 5 in for y right here, and negative 5 times negative 3 is positive 15. And I'm going to finish solving that. I subtract 15. That's x. I divide by 4. I get negative 3. All of these represent a point where the lines cross. This means the lines do not cross. Now, when they both say y equals, we did one like this already, we have to set this thing equal to that thing. So I'm going to say negative 1/3 x minus 6 equals 3/4 x plus 7. This is a fractional equation. To get rid of the fractions, I really need to get rid of the denominators. And the number that both 3 and 4, those are my denominators, go into is 12. So I'm going to distribute 12 all the way across this. And when I do, I get negative 4x minus 72 equals 9x plus 84. I'm going to subtract 9x over here and add 72 over here. I have negative 13x equals 156, so x is negative 12. So my front number is negative 12. It doesn't matter which one equation you plug it back into, but I have negative 1/3 times negative 12 minus 6. I think that's negative 2. Again, that's the point where the lines cross. Moving on, I have inequalities. So to decide whether it's a solution, it has to be in the shaded area, or it has to be on a solid line that surrounds, like, is a boundary of the shaded area. And then it can never be on a dash line, nowhere on a dash line. So 0, 2 is right here. That's a yes. 1, 5 is right here. That is a yes because it is the intersection of two solid lines. 2, negative 3 is right here. That's a no. Negative 5, negative 4 is here. That is an intersection point, but it's a no because one of the lines is dashed. Nowhere on a dash line works. 2, 2 is right here. That's a yes. 6, 0 is right here. That is also a no because that intersection point is part of a dashed line. So here, to graph this, I first need to rewrite it. I need to subtract 3x to the other side, so it'll be a negative 3x. I need to divide by negative 4. And you need to notice we are dividing by a negative number. that means that this inequality sign flips. And I have positive 3/4 x minus 2. So this is going to graph as a dashed line, and it's going to be shading down from it. Less than is down. So I'm going to start at -2. I'm going to rise 3, run 4, rise 3, I can't count, 1, 2, 3, 4. This is going to be a dashed line. If you accidentally make a solid line, you're going to erase little parts of it, make it look dashed, and I'm shading down. If you want to see the shortcuts again, less than or equal to or shade down, greater than or equal to or shade up. Here, I'm graphing both of these on this grid, and they're both solid lines because of the or equal to. Oh, this should be a Y right here. Got a mistake there. So, I'm going to start at -3. I'm going to rise 3, run 5, rise 3, run 5. That's going to be a solid line. I'm going to shade above it. This starts at 2, goes down 1 over 2, down 1 over 2. That's going to be a solid line. I'm going to shade beneath it. And my solutions are where the shading overlaps, and you need to go back and make that look darker so it sticks out. You do not need to erase these. I will know as long as you make that darker. So those are solutions. There's no solutions here. These are not solutions for the system. Since I have 2 equations, my solutions for the system are right there. You're skipping 17. It is not in the test, so do not worry about it. Here we're going to write equations. So it doesn't ask us to define the variables, so I'm not going to. Cal is 13 years younger than Sarah. Sum of their ages, sum means add, is 57. How old is Cal? Well, I can take this and plug it right in there. It's called substitution. If you want to put a 1 here to say that's what you're putting it behind, that's fine. I have 1 times C plus S equals 57. And I am substituting in an S minus 13. So I have S minus 13 plus S equals 57. And S plus S is 2S. If I add 13 here, I get 70. So Sarah is 35, but I don't want to know how old Sarah is. I want to know how old Cal is. So I can find Cal's age by plugging in 35 for Sarah and subtracting, so Cal is 22 years old. And if you choose a different way to solve that system, as long as you get that Cal's 22, it's fine. So they have defined the variables for us here, A for adult, C for child. We have 2 adults and 6 children, cost $92, and 5 adults and 7 children, cost $154. It asks for the price of a child. I'm going to multiply the top by 5 and the bottom by 2. And I'm going to notice that I need one of these to be negative, and I'm going to pick that one. So I have 10A plus 30C equals 460. And I have negative 10A minus 14C equals negative 308. These cancel. I get negative, I get 16C equals 152. And I, after dividing, get 950, or 9.5 for a child. And since this is a price, you have to put a 0 on the end of it because that's how money's written, and you need a dollar sign. That's the cost of a child. Now here, if you read through this, go ahead and read on your own. It's talking about X's and Y's, and it's saying X is the number of student tickets, Y is the number of adult tickets. So if X is the student tickets, and students cost $4, you are going to need a 4X plus 7Y. And if you look, this one doesn't have 4X plus 7Y. This one doesn't have 4X plus 7Y. And this is money, so this has to total the amount of money. And that means it's this one. Plus, my total number of tickets is 640, so there it is. Now, these are the ones that end up being in y equals mx plus b, and it says that x is the number of cards. And so it says Tara spends this much, plus she gets $12.50 for every Target credit card. So we have y equals 275 plus 12.5x. And here, Chris gets $200 plus 15 for every card. To solve this system, we need to set these two equal to each other. So we have 275 plus 1250x equals 200 plus 15x. I'm going to subtract 200 here and subtract 1250x here. And I'm going to divide. And 75 divided by 2.5 is like 30. So it's 30 cards because it says x is the number of cards. Now, if I plug 30 back in, say right here, I'll do 200 plus 15 times 30, and that's $650. So it says, how many cards must he sell to make the same amount of money, and how much money will that be? 30 cards, $650. Now, I'm also going to do the extra review here. These are questions on the test because we crossed number 17 out. I want to make sure you know how to do these. So it says identify the solution to the system of equations. The solution is right here. And that solution is 0, negative, no, wrong. It's negative 3, 0. This is no solution. Please notice these are parallel lines that have no solution. When it's one line, what it means is I graphed one line over the top of the other. That is infinitely many solutions. Please notice that looks like one line. And back to this, when you get this solution like this, what's happening is you have intersecting lines. They can intersect any place, but they definitely intersect. So make sure you see that part. No solution looks like parallel lines. Infinitely many solutions looks like one line. When you get a solution, it's because the lines were intersecting. So here we're going to write these inequalities. So I'm going to start with the dashed line, and that is a Hoy line. And it's shading down from that, which is less than. It's dashed, so I'm not going to put or equal to, and it's at 5. The other one is a solid line, and the shading is above it, so it's greater than or equal to. The slope is 3/4. Make sure you put 3/4 x. And it crosses at 0. You do not need that 0, but you can have it. Now, it says identify an ordered pair that would be a solution of the system. You can pick any point in the shaded area or any point along this part of the dashed line, but you cannot pick that point of intersection because on the solid line, I'm sorry. But you cannot pick anything on a dashed line. So I'm just going to pick the ordered pair -6, 2. That works. Now you need to pick something that's not a solution, so it falls outside that. So I'm just going to pick 8, -2. You could have other answers besides these. There's lots of points in the shaded region. There's lots of points not. Thank you.